Welcome to Chapter 10 as we look at the rational consumer, making decisions and rational decisions on the margin. So what are we going to look at? We're going to look at how consumers choose to spend their income. How do they decide and make those decisions about what they're going to buy and what they're going to consume? How do they maximize their utility and make sure that their satisfaction is still being derived from that consumption? How do we look at the principle of diminishing marginal utility in terms of it affecting what we buy and what we consume? And then how do we arrive at what is our optimal consumption bundle based on the fact that we know that we are going to be experiencing diminishing marginal utility? And then how do the income and substitution effects have an impact on this as well? So you may remember we looked at this way back in the first unit, this idea of thinking at the margin, measuring the marginal benefit and measuring the marginal cost, and trying to find places where they are equal in terms of continuing to do the marginal benefit as long as it exceeds or is equal to the marginal cost. And in this case, the first movie, clearly a lot of benefit. Second movie, definitely still benefit. Third movie, benefit is not greater than the cost, and therefore we probably would not see the third movie because that benefit doesn't exceed or equal our marginal cost. So this is the idea of thinking at the margin or marginal analysis. This idea of thinking at the margin is doing something additionally, having an extra slice of pizza, hitting the snooze button one more time. This is the idea of thinking on the margin. So deciding to go to the mall, how long are we going to stay there? Maybe we end up seeing friends. Maybe we go to a couple of stores and decide to buy something. What do we decide to eat? Maybe we decide to get dessert. All of these decisions are made on the margin. So we're going to continue to do something as long as the marginal benefit is greater than the marginal cost. But once the marginal cost equals marginal benefit, we're going to stop, because otherwise we would continue on, and our marginal cost would exceed our marginal benefit, and therefore we wouldn't be deriving more benefit than cost at that point. And therefore we wouldn't be getting the satisfaction we once were. A great example of this is actually an article that I saw in the Post over the summer, and it talked about the life of a cheeseburger, if you will, in the pandemic, and how these marginal decisions that are being made are really impacting lots of people just by deciding whether or not to eat one more burger and to have one burger. And the marginal decisions that producers make, that consumers make, all of this, and it's an interesting story, check it out in the chapter notes, but all of this is really centered around the idea of marginal analysis and making these decisions at the margin that impact countless thousands of people because of people choosing whether or not to eat a cheeseburger and how much to pay for a cheeseburger. What benefit are you deriving from that cheeseburger? So we look at marginal utility in this chapter, the idea of utility and consumption. Let's take a look at some terms. Utility is this measure of satisfaction. We use this unit called a util essentially to derive this utility. And the idea here is we're going to put together the satisfaction of a particular group of products in what we call a consumption bundle. And we look at them in terms of how much of each item should we buy. Should we buy more of one item than the other, and vice versa? That's our consumption bundle. And we're going to measure the utility in looking at this to determine how much of each item should be consumed or produced or bought in that consumption bundle. So what we see here is the total utility function continues to rise as we gain more satisfaction from more clams that we are eating. And we're going to continue to see that rise. But ultimately, we're going to reach a point at which we don't need to eat any more clams. We're going to be full. Our satisfaction is going to be satiated. And as a result, we're going to experience diminishing marginal utility. We're going to reach a point. And at this point, it looks like it's about 9 clams, at which we've reached our peak of total utility. And now that marginal utility starts to diminish. it starts to fall. And as a result, we should stop eating. If we continue to do so, we may get indigestion. We may not feel well. Maybe we're nauseous. Those types of things lead us to the idea that we shouldn't continue to consume at that point. And marginal utility essentially continues to fall. The idea here is at the margin in terms of that what's being consumed, it's going to be diminishing over time. So what we see here is we start a marginal utility between 0 and 1 clams, which makes sense. We derive the most utility from the first item that we're eating. Think about a pizza. The first slice is always the best because it is piping hot, it's fresh, you're hungry, and you're ready to eat. So the first piece is always more delicious than the second and the third. And you can see it diminishes in terms of its utility over time because we're getting satisfied. We're getting full of the items that we see here. So marginal utility is this idea that we're deriving the change in total utility between consuming one good and the next additional unit. The marginal utility curve demonstrates this graphically, and we know that it is diminishing over time because as we continue to consume an additional unit, one more slice of pizza, we're being satisfied, and as a result, we don't need that next piece as much as we needed the piece before. And that leads to that principle of diminishing marginal utility that we see here. Now, budgets are constrained. We know that there's only so much money that people have. And again, just like production possibilities, there are consumption possibilities. And a budget line or a budget constraint that we see here is going to keep a consumer from buying whatever they want to. This is going to lead to making decisions at the margin as to whether we buy more potatoes or more clams. Sammy cannot buy everything that he possibly wants. He's going to have to make some decisions here. Maybe it's more potatoes this week, more clams next week when he gets paid again, because there is a budget constraint in those terms. Now, if Sammy gets a raise at work or a promotion, and all of a sudden he has more money to play with, then he can buy more clams and more potatoes. He's pushing out that budget line, that consumption possibilities line. If he gets laid off or fired, his consumption possibilities is going to decrease. It's going to move inward or shift inward. And as a result, he's not going to have as much money to spend on clams and potatoes. So his budget line will have diminished. And this leads to our key graph, and the only key graph in this chapter, looking at consumption possibilities. So again, it's not necessarily always a typical option or feasible that we would be making a decision between good A and good B. But the idea here is as your income changes, you get a promotion, you get fired, that can change the budget line here as well. And that's what we have to keep in mind when we make decisions on the margin about how much we're going to consume of something. So going to the Krugman textbook scenario of Sammy and his clams versus potatoes, we look at the utils or the utility that is derived from these units, the total utility that we see here. And we can see that that adds up. And what is missing here is the marginal utility, because what we need to do is calculate between 0 and 1 clams, how much marginal utility do we derive? Well, we derive 15 utils. From 1 to 2, it's only 10. From 2 to 3, it's only 6. So we can see it's diminishing marginal utility. We would do the same thing for potatoes as well. And what that will lead us to is this idea of trying to measure our total utility by seeing where our consumption bundle maximizes that total utility. So if we basically add up the utils that are being, the total utility that is being derived from the clams that are being consumed, we can see that total utility continues to rise as we talked about in the first graph. It continues to rise until it reaches a point at which it starts to diminish. It becomes negative, and then the total utility starts to fall. We can see this is maximized at 72 utils, which would be a consumption bundle of 2 pounds of clams and 6 pounds of potatoes. that is where we maximize, or Sammy maximizes, his total utility. Because if he continues to consume a bundle larger than this 2 pounds of clams and 6 pounds of potatoes, what he's going to find is his total utility now is falling. So he reaches a point at which he's maximizing his total utility, and that is ultimately his consumption bundle. So if we look at going back to that total utility graph, we can see his utility is maximized here at that combination of 2 pounds of clams, 6 pounds of potatoes. If he continues to consume a different bundle, say 3 pounds of clams and 4 pounds of potatoes, he is going to not be maximizing his optimal consumption bundle. His utility is not maximized at that option D or E or F, or even B for that matter. It is maximized at where we find the total utility is greatest, and that is going to be at this 2 pounds of clams and 6 pounds of potatoes. Now, we can also look at the marginal utility per dollar. If we know how much Sammy is able to spend based on this, we can look at the marginal utility per dollar and find that consumption bundle as well by looking at what Sammy has to spend in this particular environment. And I believe the budget line had his consumption bundle at $20 a week. So if he has $20 a week in order to spend on this, we can see then that, again, going back to his marginal utility per dollar, this is going to be, again, your marginal utility per dollar needs to be equal here between clams and potatoes. So if he is maximizing his marginal utility per dollar, again, then they have to be equal between the two, and he only has $20 to spend, he is going to he's going to see that, again, between 150 and 250 is going to be 2 pounds of clams being consumed, as well as, again, potatoes. Because, again, with only $20 to spend, he's going to see he's spending $8 here on clams. And with 6 pounds of potatoes at $2 a pound, he's going to spend $12 over here. So that's going to be his budget, his $20 budget in those terms. Now, you could look at other options and say, oh, well, 75 cents is the marginal utility here. Maybe he could consume 10 pounds of potatoes, but that would be $20 already, and there's no room for clams. And in this marginal utility per dollar being equal, he would have to consume 4 pounds of clams in order to get the marginal utility per dollar that is equal to the 10 pounds of clams, or the 10 pounds of potatoes over here. So here, the marginal utility per dollar isn't equal at any other place other than 2 pounds of clams and 6 pounds of potatoes. And we'll look at another example that tries to address that, because I know that it's maybe a little confusing there. But again, here we see, again, the optimal consumption bundle is what he's looking at here in terms of the marginal utility per dollar. And that's going to intersect at point C at 2 pounds of clams, 6 pounds of potatoes. To go further, in terms of option B, we can see that that's not going to match. The marginal utility per dollar does not match for both of those. It's $1 over here, $3 over here. So graphically, that's easy to see. What you're going to be more likely to see is this type of a scenario in which your marginal utility per dollar is here, or at which your total utility is being derived, and you're just maximizing your total utility there. So the optimal consumption rule basically says we are trying to find our optimal bundle at where the marginal utility of one item divided by the price, marginal utility per dollar, is equal to the marginal utility of another item divided by the price of that item. So marginal utility per dollar of one good should be equal to the marginal utility per dollar of the other good. That is where we're going to maximize our utility. That is where we're going to have what we call an optimal consumption bundle, or the optimal consumption rule. Now, if you think about this in terms of roller coasters, our warm-up today is basically about this idea of roller coasters. And, how do you decide whether to ride on another one? The Guinness Book of World Records has this roller coaster aficionado basically on a roller coaster for 16 days, 400 hours. I think based on the pillow and the fact that he looks like he's asleep, he is probably experiencing diminishing marginal utility at this point. So imagine you're really thirsty and you need a bottle of water water, what is that first sip going to feel like to you? It's going to be precious, just like that piping hot first slice of pizza is going to be precious. Now, somebody could offer you all kinds of water, but that case of water isn't going to do you any good until you have the first sip, the first bottle. That is going to be worth more to you in terms of your utility, your satisfaction, than anything else. And that's what we're trying to quantify here, is that utility or satisfaction that we experience. Because as we continue to consume more of that water, we're going to experience diminishing marginal utility. I don't need to consume an entire case of water to be satisfied by drinking a bottle of water. That is really the biggest difference there. And so the point here is you're going to continue to consume as long as your marginal benefit is greater than your marginal cost. But once it equals, then you're basically making a decision internally, and we do this all the time, that we're going to stop drinking water because we don't need it anymore. We're happy where we are. We're not going to continue to consume it just because it's cheap, okay? Oh, I got that for $2. You know, that case is really cheap to buy the whole thing for $2. I'm going to continue to drink it all because I got a good price on it. Well, if we run out of room in our stomach to house this water, our benefit is going to be less than our cost at that point, and we're going to be nauseous. We're not going to feel well. That is not going to be a good satisfaction type of feeling that we're going to want to do again. So we look at calculating marginal utility by measuring the difference between the two in terms of one slice of pizza and another. We also use this usually with ice cream here, and unfortunately we're not in school to be able to do that. But the idea here is from 0 to 1 slices, we derive a marginal utility of 8 utils. We're going to see for the second slice, it's only 6. For the third slice, it's 5. For the fourth slice, it's 4. And you can see we're experiencing diminishing marginal utility here. Our marginal cost is $2 a slice. So where is our marginal cost equal to our marginal benefit? It's at 5 slices. We maximize our total utility at 5 slices, because to do more than that, our marginal utility, our marginal cost would exceed our marginal benefit at that point. The 6th slice is only a marginal benefit of $1 for us. So in this case, we're not going to continue to eat the 6th slice. We're going to stop at 5. And that is because marginal benefit equals marginal cost at 5 slices. So the idea here, what if you never get to a point at which marginal benefit is equal to marginal cost, because you end up going right by it. First you're ahead of it, and then all of a sudden you're below it. You go from $3 in marginal benefit to $1. Well, you're always going to stop before marginal cost exceeds marginal benefit. You don't want to go any further, because if you do, again, you're going to experience nausea, indigestion, you're going to feel full, you're going to feel gross, and you're not going to want to do that again. So that's why we always look at marginal benefit as being greater than or equal to marginal cost. And in many cases, it probably won't be equal. It will be greater than marginal cost, and that's probably where you should stop, especially in this case, because if you go too far, your marginal cost will exceed your marginal benefit. You won't be deriving any benefit or satisfaction that you'll be able to get out of it. So in terms of consumer behavior, if we look at taking a vacation, we're going to Tahiti or Chicago. We're going to derive more utils from Tahiti than Chicago, especially in November, right? So it's really important to note this. So now we look at the price. Well, it's $3,000 to go to Tahiti, only $500 to go to Chicago. So our marginal utility per dollar, again, 3,000 over 3,000 is 1. 1,000 over 500 is 2. We're deriving more utils from the trip to Chicago than the trip to Tahiti, because the cost, the marginal utility per dollar, has an impact on what benefit we derive from this. Now, you may look at cost benefits and say, hey, I want to go to Tahiti, it's warm, maybe your marginal utility in utils is greater than 3,000, and it may be 6,000, and then it is equal to Chicago, so you could do either one. But that's the behavior that we go through all the time in our minds, weighing the costs and benefits in order to figure out what it is that we should do. So let's take a look at this movie example again. So to get the marginal utility per dollar, we're going to divide the marginal utility of the first movie by the price, which is $10. So in this case, we can see $30 divided by 10 is going to get us 3. The idea of $3. We're going to do the same thing for the marginal utility of go-karts. The first go-kart, $5 for the go-kart, and a marginal utility of 10 utils in terms of satisfaction. So that's going to give us a marginal utility per dollar of 2. And we'll do the same thing for each one of these, again, dividing the marginal utility by the price in order to arrive at the marginal utility per dollar for each. Now, we're trying to maximize utility. Remember, we're looking at this rule. The marginal utility per dollar of good X should be equal to the marginal utility per dollar of good Y. This is the idea that we do this all the time. We weigh the costs and benefits of 2 different goods or more to get the marginal utility per dollar in our mind. It may not always calculate to the marginal utility per dollar, but we're looking at the price and the benefit that we get out of the item to determine whether or not we should buy it. So in this case, you have to match the marginal utility per dollar, 1 and 1, 2 and 2, and those are basically our only options here. We don't have a 0.5 and we don't have a 3 over on the go-kart side. So we have 2 options, either a marginal utility per dollar of 2 or a marginal utility per dollar of 1. And if we only have $40, what combination of movies and go-karts is going to maximize our utility? Well, if we look at the idea of the utils in terms of marginal utility per dollar of 2, we're going to have 2 movies, which is $20. We're going to have 1 movie, which is $5. And that is going to lead to a $15 gap in how much we can spend. So our marginal utility per dollar probably not providing the maximum satisfaction in the marginal utility per dollar of 2 here. Now, if we look at the marginal utility per dollar of 1, we see that 3 movies times a price of $10 is $30. And the idea here of go-karts, 2 go-karts at a price of $5 is going to lead us to $10. $10 plus $30 is going to lead us to that $40 price budget that we have. And we're going to derive the most satisfaction from that scenario because the marginal utility per dollar is equal, and we have used our budget. We've used our entire budget on these 2 items. So we're going to go to 3 movies to derive that marginal utility per dollar of 1, and we're going to ride 2 go-karts to get a marginal utility per dollar of 1 as well. That's going to maximize our utility there. So how much is the total utility from 3 movies and 2 go-karts? Well, we can see here what we're deriving from that in terms of the total utility by looking at the marginal utility for each one. Now, all we need to do in order to calculate this is add up the marginal utility for the items where we're maximizing our utility based on marginal utility per dollar. So we would add up 30 plus 20 plus 10. That would give us 60. And then we would add up 10 plus 5, because again, it's getting us to the marginal utility per dollar of 1. And that would be a total utility of 75 in terms of 3 movies and 2 go-karts. Now, the total utility for 2 movies and 4 go-karts is going to be 30 plus 20 in terms of the movies, so that's 50. And then 4 go-karts is essentially going to be 18. So in this case, you have 50 and 18, 68 in terms of your total utility at the 2 movies and 4 go-karts item. So your utility is going to be maximized at the marginal utility per dollar, and this would prove it. 75 versus 68. 75 has it, and that would be at the marginal utility per dollar of 1. So we would go to 3 movies and we would ride 2 go-karts in order to maximize our utility in this example. Can't stress enough the importance of the utility maximizing rule. The optimal consumption is based on marginal utility per dollar. What is the marginal utility per dollar of one unit versus the marginal utility per dollar of the other unit. And there's some really great questions in the take-home quiz in Activity 2-2 that we'll be going over in class that I think will help with that. So definitely don't skip those activities. Do those practice questions. We have some we'll do in class as well. So again, going back to that optimal consumption bundle, we're looking for total utility that is greatest here. That's going to get us to the combination of 2 pounds of clams, 6 pounds of potatoes, and that is where Sammy would maximize his utility in this particular case by looking at the total utility in this example. He could also look at it as marginal utility per dollar. Where is that maximized? If he has a budget of $20, that's going to be at, again, 2 pounds of clams, 6 pounds of potatoes. And we see that playing throughout here in terms of that optimal consumption bundle is where his marginal utility per dollar is equal for the two goods. Now, a couple of items just to mention here, that this has to be the same for all goods and services in the consumption bundle. So the marginal utility per dollar must be equal. If they don't equal, then you don't have an optimal consumption bundle. So that really makes it a little easier in terms of looking at some of those examples we did back here, because they have to match. So that's where 2 and 1 are basically the only options, because all the other numbers don't match up between the two goods. And that helps you narrow down what you're looking at. So we're looking at a marginal utility per dollar of one good that is equal to the marginal utility per dollar of another good. And that really is the role that they play there. The substitution effect, we've talked about this earlier in Unit 1, the idea that if the price rises on a particular good that we like, we substitute the other good, and so the demand for the other good rises, because remember, price is not a shifter, but the demand for the other item goes up because it's the substitution effect at work. And the same is true here. When we have a cheaper good that is a price cut or something, that is having an effect on what we're looking at here, and that's the important aspect of the substitution effect. The income effect is essentially the same. If we have more income, we're going to be using that in order to produce and consume at a higher income, and so we're going to buy more normal goods. The exception to that would be if we're looking at Giffen goods, whereas the price rises, the demand goes up. Think potato famine. But the inferior goods are going to be for consumption bundles in which you have an income that is less than what you were used to. If you get laid off from your job or you get fired, that's when your income effect is negative and shifting inward, and that leads to a smaller consumption bundle. If you're getting a raise or you're getting a promotion and you're making more money, then the income effect moves that consumption line outward, that budget line outward, and you're able to buy more. So you're not going to be buying Spam if you're getting a raise or you're getting a promotion. That's only if you're getting laid off or getting fired that we would see that playing out there. As I mentioned, there's a couple of different problems here, and we'll tackle those in class in terms of what to address there. Check out the chapter notes, not just for those problems, but also for some really great videos here that AC/DC Econ and Crash Course have on this topic of marginal utility and utility maximization. There's a couple of good ones here. There's a funny one related to Monty Python that AC/DC uses, and also behavioral economics, again, from Crash Course. There's also the link to that article from the Washington Post on the life of a cheeseburger in the global pandemic of coronavirus, and how marginal decisions are being made that I think you'll find helpful as well. Some key terms to take a look at, and you can always pause the video here. If there's something you don't know, definitely look it up. Go back to the chapter. I think you'll find it helpful. And as we close out this chapter and look at the idea of applying utility to businesses, what satisfaction would you derive as a business owner to keep your doors open? What utils would you assign to those types of roles and impact that's taking place there? And then how is it going to affect your business in terms of what you open and what you sell, what products you have available? All of these things are what business owners tackle all the time in terms of the roles that they play and the decisions that they're making, again, on the margin. So what marginal utility would your business experience? What would you do in order to maximize utility? Again, looking at that optimal consumption bundle, the marginal utility per dollar of one good versus the marginal utility per dollar of another good. And you also have to keep your clients in mind, your customers. What is their marginal utility per dollar of buying something? How does Starbucks get people to pay $5 or $6 for a venti mocha frappuccino versus a regular coffee? That marginal utility per dollar is important here in terms of how they're able to market that and sell it and find ways to produce it at a capacity that is maximizing a consumer's marginal utility per dollar. So that's really important in terms of that respect of maximizing utility. And then the last piece, again, what does it come back to? It always comes back to measuring the costs and the benefits, the marginal costs and the marginal benefits. Again, we want to continue to consume when marginal benefits are greater than or equal to marginal costs. Hope you found this helpful. There are some answers to the take-home quiz questions. Those have also been posted on my MCPS Classroom or Canvas that I think you'll find helpful here. Here's the answers to the multiple choice. And that wraps up this chapter. So we hope you found this helpful. And again, this is what you need to know more than anything are two things. One, marginal benefit is greater than or equal to marginal cost, you continue to consume. Where do you maximize utility? Where marginal utility per dollar of one good is equal to the marginal utility per dollar of another good. All right, so have a marginally beneficial day.